In this video, I'm going to look at programming Python on a BBC microbit. In particular, I'm going to look at two different implementations of Python and how these differ. These are MakeCode Python and MicroPython as implemented on the microbit. The more traditional version of MicroPython, which is used in the online Python editor and offline editors such as Mu, has been available since the release of the microbit. The MakeCode version of Python, which is designed to integrate with the block-based MakeCode, was added in 2020. There are some pros and cons to both, but I had quite a few surprises while I was making this video. I'm going to start by creating a physical computing project using an LCD display. This example will show some of the reasons and issues with each implementation. I'm going to show a reason for choosing the MakeCode implementation of Python. I'll then show you some of the negatives of using MakeCode Python compared to the alternative versions of Python. As I said, the project will use an LCD display. I've already created this project using MakeCode block-based programming and JavaScript. So if you're interested in those, there's another video linked to in the description. If you've already watched that earlier video, then you'll see some of the hardware part of the video repeated. So feel free to skip over the next chapter and pick up later on when we start talking about Python. So let's have a quick look at the hardware. Obviously we need a microbit. You can use either version 1 or version 2, either will work just as well. We also need a breakout adapter. The one I have involved soldering, but you can get one that's already pre-soldered. The important thing is it needs to have pins 19 and 20, which are the ones used for I2C. You also need a 5-volt power supply, and this can be the same power supply as used to power the microbit, but that depends upon your breakout board. In my case, I needed a separate power supply, and I just used a micro USB breakout board on my breadboard and connected that through another USB cable. Obviously, you need a 1602 LCD display. Specifically, you need one with this I2C adapter, often referred to as I2C. If you're searching for one, they are commonly available and they are fairly cheap. And then you just need some jumper wires to connect them all together. There's loads more information on my website. If you see the link in the description, and that will show you all the things you need and a bit more explanation about them. If you look at the LCD, you'll see that it's mounted on a PCB. And if you turn it around on the back, you'll see that there's then another PCB that's piggybacked on the back as a add-on extra. This is the I2C adapter. This adapter provides a way of sending the information as serial data using only 3 wires. Without this, then you'd need to use a lot more pins on the microbit. And so that's why this is quite a popular way of controlling these LCD displays. To wire it up, you just need to connect the ground of the LCD display I2C adapter to the microbit. The SDA connection goes to pin 20 and the SCL connection goes to pin 19. And then you need to connect the 5-volt power supply to the LCD display. If it's an independent power supply, you'll also need to connect the grounds together. When using the microbit, then I recommend using the Chrome browser, as this supports connecting to the microbit directly. The reason I created this in MakeCode is because of the lack of working library for the microbit using MicroPython. I did find some libraries that said they were for the microbit, but they appeared to use a different implementation of I2C. So if you do know of a library that is easier to use with the, say, the Mu editor or the regular microbit MicroPython, then let me know in the comments. I'll look to that into another video. But for this, I'm going to take a look at the MakeCode implementation of Python. You can go that by Let's Code, and you'll see there's an option here for the MakeCode editor or the Python editor. So the Python editor is based around implementation of MicroPython, whereas the MakeCode editor uses the Microsoft MakeCode. I'm going to start a new project here, which I'll call Test LCD with Python. So the way that Microsoft has implemented this using MakeCode is to create another language called TextScript. And the idea is that the block code, the JavaScript code and the Python code is all converted to this TypeScript before it's used. And this then provides a common language, and in theory you should be able to do everything the same way in any of those languages. So in this we're going to be using the Python. And the first thing to do is to add an extension. So this is going to provide the code to communicate with the LCD display. If you go into the extensions and search for LCD, you'll find a few. I've had a few problems with this one, which is the I2C LCD 1602. So instead I'm going to use the MakeCode LCD 1602. This is normally used as part of the MakeCode hardware add-ons, but it works perfectly well with any LCD display using the normal I2C backpack. I'm going to start by creating a really simple example just to show you how you would implement this. As you can see, it's already created a for loop that we can use to run continuously. I'm not going to touch that at this stage. I'm literally just going to take some of the LCD code, and we're going to start with the connect, which is the initialization. This uses address 39, which matches the address that is on the backpack of my particular LCD. You can change it on the LCD backpack by shorting across some solder points which are designed for that, but we'll just use the standard decimal 39. And then literally just going to have it output a message. So uses the show string, and you can put the message you want to display. Hello. I'm going to put hello from, see why in a minute, and then we just use this position determines the start position, which in this case is going to be position 1, and for 16 characters is the full row, because I've got a 16 by 2. And then for the second line I'll just repeat that, and I'll just put a different message in there. And I'll change this position to position 17. So that's the first position on the second line. And then I can download this to the microbit. Just connect my microbit in first. And it's connected straight away as soon as I've done it. If it hadn't, then you can click connect on there. And then we just download that, and it will download it to the microbit and then display it on the screen. And now it's completed the download, and it just says hello from www.penguintutor. Doesn't actually fit the full string on there. So with that, you can see how you can send some basic messages to the LCD display. It's a bit more verbose than I'd like. It's referring to make a bit. It's referring to make a bit, and it's quite a long wordy message, but you don't really need to worry about that because you can just drag and drop it and then add the rest of your code just using normal Python. we go back, I've got a stopwatch here that I've created in Python. So this is basically an implementation of the stopwatch that I created in MakeCode and JavaScript on the previous video. It works by a few things. So this section here, which isn't in a function, so it doesn't have a def in front of it and it's not indented. This is the initialization code. It monitors the state whether it's running or not, which allows you to pause and play, and then it has a timer which counts the time. We run the connect, which you saw previously, and we start by putting a message that says stopwatch on the first row. There's a duplication of those there. Just remove that. And that's the initialization. Then there's the forever loop, and this will run, as it says, forever. And it's going to refer to the timer, and so it just repeats showing the message. And you'll see here that it uses a string, a blank string, followed by string and timer. I'll explain about that in a short while. We'll come back to that. But basically it shows the number on the timer, and if it's running, then it will pause and it will increment the timer. If it's not running, then it will loop around again, so that this is running constantly. Then, depending upon whether the button is pressed, button A is used to control whether it's running, basically like a play pause button. And it does that by just setting this running to either false to stop it or true to start it, and it just toggles between those. And button B is used to reset the timer. So it uses the timer as a global variable, sets the timer to 0, and then clears the screen and then displays the stopwatch. The reason for clearing the screen is that if you've got a long number already on there, that will clear that away, and then shows the value. And this is all the code that runs the stopwatch. And it's, as I say, the same as the previous video, but all written directly in Python. Now, download that, and then that runs. So here it is running. Press A, which is to start the timer. Press the A button again, it will pause the timer. And then I can use the B button to reset that back to 0, and the A will start it again. So one of the things I want to demonstrate at this stage is a bit about the behaviour of MakeCode, and as I say, relates to it using this underlying programming language called TypeScript. So I did originally write this directly in Python, but some of the code, and particularly the formatting, has changed. For instance, I did write these on one line. The Python recommendations are actually to split lines up if they get too long, but I thought it was easier to understand as a single line. So let's just show you an example I did. We can put it all on one line. However, it's not necessarily going to keep that, because if I switch to blocks, remember this is line 13, the stopwatch, and then go back to the Python code, you see that line has been split back up. Not a problem, it's just formatting. But another thing is that I didn't write this either. The normal way I would put a integer number into a string is by just using this str function, which will convert that to a string and then puts that in there. And that is perfectly valid Python code. I use it all the time. But if I click on the blocks and then go back to the Python, it's changed that line again. And what it's done is created an empty string, concatenated that with the string. It's even added an extra pair of brackets inside that. I really don't know why this extra pair of brackets is. It's basically trying to create it so it's a tuple. But again, the formatting's changed a bit and it's basically changed some of my code. Not a problem because both are valid, but that was just one of the observations that I had. And if we go back to the block now, you'll also see that it's put this join in. So instead of just having the timer in, it actually says join timer to nothing, literally, and it's just a little bit of a annoyance, but not really a problem. A bigger thing is I'm going to come on to shortly, but we'll just take a look at the other version of Python. Right, to show you this example, I'm going to go out of this and we're just going to go to microbit.org. So we're going to completely close out of that and go to Let's Code and see this other Python editor, which is the microbit version of MicroPython. I'm going to connect to the microbit first. And now what I'm going to do, I'm just make this nice and big first so you can see it. I'm going to create a very short piece of code, just a simple loop that's going to be a countdown timer. I'm going to use a for loop, for I being an integer, in the range. I'm going to start at 10. I'm going to go to 0, but that actually stops at 1, the previous number. And I'm going to do this by decrementing one number at a time. So what that means, it's going to go 10, 9, 8, 7, 6, 5, 4, 3, 2, and then stop on 1. And for each of those, it'll set I to that number. So now we can use display.show and then the number just as I. And then we just need to use sleep and then the time in milliseconds that you want it to sleep for. So I'm going to do 1000 milliseconds. So that's going to do once per second. It's going to start at 10, decrement once per loop, sleep for a second, and then carry on. So we can now just flash that. If this is the first time, then that'll take a bit longer. I've already downloaded it to this particular microbit, so this is downloaded straight away and it's counted down and stopped at 1. Just as you would expect using Python. I'm going to try and implement that now using the MakeCode MicroPython. I'll just create a new one. Test. Countdown. I'm going to go into the Python part of this. And we don't need this forever. We can just delete that or we can leave it. It doesn't make any difference. What we're going to do is basically the same. So we're going to try the for I in range 10, 0, minus 1. And this it uses a different display actually, so I'm just going to basic and find the display, show number in this case, and then the number would be I. And then I'm going to use sleep, again uses a slightly different sleep called pause. basic.pause. So this is the same code, except it uses slightly different names here for this. Instead of display.show, it's basic.showNumber, and instead of just sleep, this is basic.pause. So these are a few bits that are specific to the MakeCode implementation of Python. The problem comes with this is if I try and download this, and then I'll use this emulator actually to demonstrate how it works. So I've downloaded this and the screen is completely blank, and the same on here. So basically it's just not running. And as you see, this is perfectly valid Python, as you saw when we created it before. It just doesn't work. And I believe the reason is that the implementation of TypeScript doesn't have the ability to have this for loop with a range that counts down. You can only count up. So if I did, to get it working, I could do 0, 10 and 1, and then I'd have to do count 10 minus I. And this is the only way I can get this to work. So instead of incrementing down, we have to increment up. Or the other way would be to create a different kind of loop, but you wouldn't be able to use this for loop. So if I try this, you'll see that this works as expected, and as the previous one did, using the normal MicroPython. But if I change this to try and count down instead of up, as I did before, then it just doesn't work. Nothing happens. There's no error message shown anywhere or anything to explain why it doesn't work. We try and switch the blocks, it just says Python code as well. It doesn't understand that. I try and move that back to, oh, this isn't going to work because of that. I haven't done the decrement. There we go. So if we get rid of that third parameter, then it does work. Also, we can actually still have that third parameter. Here it's converted it to a range just to 10. If I put that third parameter in as 2, so it's counting up, but counting up by 2, you'll see that that does work. But if we go back to the block code, it just doesn't like it. It just says that's Python code and doesn't show it at all. So there's a bit of a limitation of the MakeCode version of Python. I find that quite frustrating that it doesn't support the full range of code that MicroPython does. And this could potentially cause problems with children that are learning Python, that are wanting to move between MicroPython on, say, a Pico or a Raspberry Pi, running normal Python and trying to then use MakeCode. However, the one advantage of using this is that there are some extensions that just don't seem to be available for the microbit using MicroPython. So we should use MakeCode Python or MicroPython. Personally, I would prefer to use MicroPython. Just close that so that we're no longer connected. Part of the reason being that this is closer to the normal Python that you would use if you're, say, programming on the Raspberry Pi. And it could be quite difficult for someone that's written some code on the Raspberry Pi, then trying to do the same code on the microbit and it not working the same. However, if your particular hardware that you're wanting to communicate with, such as this LCD display, is not provided for the microbit version of MicroPython, then it may be that you have to use MakeCode version of Python instead. This is something I wasn't aware of before, but it's something that hopefully now you can be aware of, and you can make that choice of which particular version of Python you can use, knowing the pros and cons of each one. Hope you found that useful. If you did, please give it a thumbs up, and if you're not already subscribed to my channel, please do so to get notified of new videos I create, which will include the microbit but also Arduino and Raspberry Pi. And thanks for watching.